Okay, now, they calculate the solubility of silver iodide in 1.5 molar ammonia. Now, this one is such a short problem, it should catch your eye as far as what it's asking for here. And it doesn't say the silver iodide, doesn't say anything about in solution, so we just know the silver iodide is sitting on the bottom of the container, and it breaks up into silver ion and then iodide ion. And the KSP for this reaction is, should know this one, we use it so often, 1.80 times 10 to the minus 10. And I want to get this. Oh, this is silver iodide. Okay, sorry. I was looking at silver chloride. I was going to say that doesn't seem nearly as small as it should be. 8.3 times 0 times 10 to the minus 17. Sorry. So I said I should know it offhand because we use silver chloride all the time, but it's not silver chloride, silver iodide. And then the silver ion, because there's ammonia present, can react with 2 ammonia to form a complex ion that we know is going to have a high Kf. It's going to be very stable, and that should draw, since it's reacting with the silver is being used up, it should draw the silver iodide more into solution. So by the addition of a ammonia to silver iodide that's sitting on the bottom of a solution, a saturated solution of silver iodide, you can draw more in. So let's see how much more. The amount of silver iodide that will go in by concentration will be actually the square root of this. So without any ammonia, we'd expect to have 9.1 times 10 to the minus 9 molar silver iodide in solution. So very, very small. Let's see if we can boost that up by making this Kf is going to be 1.70 times 10 to the 7th. Now it looks like, so oh, we have this, we have to flip it around. No, this is what we're trying to do is make this solid go into solution more. So if we're taking this as 2 steps. This breaks up into this ions, and then the silver goes on to react with the ammonia to create something very, very stable. So you can see KSP here, it's very small, but this is a very large number, so we drag it on, and as we take away silver, this reacts more and more, and we want to drive it into solution. So we do a trick here. Let's add them up. We have silver iodide. See, the silvers cancel. Plus, so it really is saying the silver iodide sitting on the bottom of the solution reacts with the ammonia in solution to produce iodide ion and silver silver ammonia complex. And the K for this is going to be KSP times KF. Let me make sure I'm on. Yep. Which is going to be 1.41 times 10 to the minus 9. So that means that if the concentration of iodide times the concentration of silver ammonium complex over equals that number. I keep debating whether or not to mention the name of this complex. That's going to be a next chapter. We don't have to do that for now. And then you see that we have, this is nothing here. This is going to be 5 molar, 0, 0, minus 2x, I should say, plus x, x. So we put an x squared over 1.50 minus 2x squared is equal to 1.41 times 10 to the minus 9. All right, the approximation is going to hold, and we can take the square root of both sides, and we end up with the constant x, which is the concentration of I minus, is also the concentration of AgI in solution. That's our solubility, and we'll say molar solubility is 5.64 times 10 to the minus 5 molar. Still small, but if you remember that on its own, it was something like 10 to the minus 9. So we've made the silver iodide about several thousand times more soluble by adding that ammonia. Now let's do another one here. Silver bromide. So when you see this, calculate the solubility of silver bromide in something, some counter ion. Look up the complex ion table and see that silver and this ion do make something, and then the silver bromide break up into ions, you can see that it's going to be one of these problems. That there's not enough information to do any other problem. It's the set amount. It's a very short statement, so it only will work for this kind of calculation, in case you get lost. So trying to figure out what to do with all of these different versions is you definitely don't have enough information to go do any other type of problem. Now the silver will react with two thiosulfates and produce this complex. And this has a Kf of 2.90 times 10 to the 13. If you add these up, then you get the silvers cancel, and we have AgBr plus 2S2O3 2 minus goes to Br minus plus silver, and the K here is going to be 14.5. I want to double check something really quick. Let's make sure that I have, what was I looking at here? Yeah, that's right. Just wasn't, thought I might have skipped something, but I have it in there. And then the expression here, the K expression, doesn't even, we just call it KC, unless they call it something else. Let me see if they have a name for it, because it's, yeah, they just call it KC, and that's the best thing to do. Over, now, I didn't leave a lot of room here, but we know this is going to be plus x. This is 2 molar minus 2x, so this will be x squared over 2 molar minus 2x squared equals 14.5. Now the approximation doesn't hold, because 2 divided by 14.5 is not greater than 100. That's okay though. It's set up so that, take the square root, nice. So we don't even have to worry. So the last one we were able to get rid of that x term, but here we can't. So when you work it all the way through, you'll find that x is 1.58 molar. And so this is actually the concentration of silver bromide that will go into solution with the addition of lithium thiosulfate.